Factor quadratics by grouping. All right, there's two ways you can go about this. They both start off the same way. So I'm going to start off, and then I'll show you the two different ways you can solve it after that. So we have our A term, our B term, and our C term. I like to start off with a diamond. The top is A times C, and the bottom is our B value. So our B value is just negative 24. And our top value is, once again, A times C. So negative 7 times negative 9 gives you a positive 63. So now what we're going to do is we're going to create a factor tree of this number, of that number right there, 63. I'll do it on this side. More space. And you're going to divide it by the numbers starting at 1. 63 divided by 1 is 63. 63 divided by 2 is a decimal, so you're going to leave it there. 63 divided by 3 is 21. 63 divided by 4 doesn't work. Divided by 5 doesn't work. Divided by 6 doesn't work. Divided by 7 gives us 9. Now what you want to do is try and get these numbers, a set of these numbers, either that number, numbers, or those numbers, or these numbers, to add up to your B value. Okay? Now, our B value is negative, so we're going to have at least one negative number. 63 and 1, we can't get to 24 there. I can get 62 to 64, but that's about it. 21 and 3, that's a little more interesting. Make them both negative. Negative 3 and negative 21. What does that add to? That adds to negative 24. So those are our numbers. Okay. So this is where you have two different methods. I'm going to do one method first, and I'm going to do it a different way second. And you can pick which way you like. It doesn't matter to me which way. So, let me erase some of this work. So it's out of the way. We'll get rid of this too. We don't need that anymore. All right, so our numbers are negative 3 and negative 21. So you first write off 7x squared, and then the back is negative 9. In the middle, we're going to break this up into these two numbers. Negative 3x, negative 21x. And now what you're going to do is you're going to treat this as two different factors. We're going to factor these numbers, and we're going to factor these numbers. That's a bad color. Let's try that again. Let's try yellow. Okay? So in negative 7x squared and minus 3x, what is the greatest common factor? Well, 7 and 3 are prime. I can't pull that out, but they're both negative. So we're going to pull a negative number out, and there's an x in both. What is left over? Negative x times what is negative 7x squared? That is a positive 7x. Negative x times what is negative 3x? That is a positive 3. Now we're going to move over to the next one. Negative 21x and negative 9. What is the greatest common factor in both of those? Well, we have a negative sign. And 9 and 21, we can both pull the 3 out. And what is left over? Well, it should be what's in here. Negative 3 times what is negative 21x? It is 7x. And negative 3 times what is negative 9? It is a positive 3. And yes, these two things are the same. So now we have a negative x right here being multiplied by 7x plus 3. And I'll make that green. Okay, this is the same, and that's the same. So we have two different things being multiplied to the same thing. So we're going to rewrite those together. So negative x minus 3, that's the stuff in the yellow, right? And then we're going to multiply that by what's in the green, which is 7x plus 3. And now we have two binomials. We factored our expression. Okay? I'll make this green just so you can see. Make it obvious. And there's our green. Okay? Now I'm going to do another way. We'll leave the answer there. Let me erase everything else. And I'll show you the other way. Call this the reverse box method. And some students like this better than the other one. The yellow and the green. It's very similar, but just a different setup. Okay. So, erase that middle one. It's a little crooked. Up here, you write the first term, then the last term goes down here, and then kind of like the last step, we're going to take what's in our blue over here, the -3 and the -21, and put them in these boxes with an x behind it. And just like we did, we're going to factor out. I like to factor out going up, so -7x squared and -21x. What is common in both of those? We can factor out a -7. Oops. There we go. There you go. -7 and an x. Okay. Now, -7x is here. We're trying to get to -7x squared. So what is missing? Well, I have the -7. I have one x, but I need a second x. So the x will go out here by itself. So what's in yellow? X times -7x equals what is in green? -7x squared. You factored that out. You're going to work your way around. X times what equals -3x? Well, it is -3. -7x times what is equal to -21x. That is a -3, +3. And then lastly, you want to check our yellows. I'll erase these real fast. So, what's in yellow? Oh, my green too. Let's erase my green. Okay. So we need to equal this, and we are multiplying this and this. Does +3 and times -3 equal -9? The answer is it does. So we have our answer. We have -7x minus 3, and we have x plus 3. Now, looking at this, you can actually rewrite the bottom one backwards. I'm going to rewrite it this way. X plus 3 and -7x minus 3. Erase. Just ignore what's in yellow right now. I just rewrote it so that these are lined up. Now, there is something that's a little different here. I have a -x, -3, but a +x, +3. But if you look at the back side, these are both positive and these are both negative. So this is the same answer. It looks like they're different, but they really are the same thing. I could rewrite these negatives as positives and move this negative out to the front if I wanted to, and then put it back inside the x plus 3. So two different ways gives you the same answer.